So today what we're going to be doing is graphing a quadratic in standard form. Again, but in this case, the quadratics aren't going to be as friendly to graphing as they were last time. This is going to be when we have graphing a quadratic that doesn't have any real roots, which means it's going to curve away from the axis and never actually touch it. This means we're going to have to find the vertex using a different method. We're going to learn about completing the square here in a future lesson, but for today, we're just going to learn two formula which are going to always find us the vertex, given it's in ax squared plus bx plus c format. This means that we're going to have to take x equals negative b over 2a, and remember, this is in the form of ax squared plus bx plus c. So for my b, I'm looking at the second number. For my a, I'm looking at the front number. And remember, if there's nothing there, we assume that there is a 1. Then we're going to plug whatever we get for this into our function, reevaluate, which will give us our y coordinate. Now, this is built off the idea that if I were to try and hand factor this, I would be having to come up with factors of, let's see, negative 9 times negative 1. So negative 9 times negative 1. That would be positive 9. I need to find factors of positive 9, which means sum, that add up to 6. So I have 1 and 9, 3 and 3. Lo and behold, we have 3 and 3, which means that we have, cool, so we can actually factor this one. Let's go ahead and factor it and see what we get. Well, when we factor this one, I'm going to split this into negative x squared minus 3x minus 3x minus 9. In this case, I'm going to pull out negative x, and I'm going to pull out negative 3. So negative x, negative 3. And that's going to give me, let's see, if I divide that, that's an x plus 3. And same thing over here, x plus 3. Ooh, which means I can pull out an x plus 3. So I have x plus 3. And then I have a negative x minus 3. And we know basically that we're setting both of these equal to 0, which means my x plus 3 has to be equal to 0 for my root 1. And my negative x minus 3 has to be equal to 0 for my root 2. I subtract 3. Boom, there's my first root. I add 3. And I divide by negative 1. And we run into our problem. When we try and graph this using the root method, which means we're not graphing the vertex, I end up with the same root. So 2, 3, negative 3, and negative 3, which gives us a problem because that means that that root is our vertex. This is going to curve away from the axis, and we don't know whether or not it's going to curve up or curve down, or how it's going to curve, where it's going to curve, what's going on. So the only way that we can figure out another point to plug in there is we could try and plug in our y-intercept, which means I can take 0 and plug that into the equation just to give it a second point. And so let's give that a shot. So I'm going to plug in 0 and say f of 0 is negative 0 squared minus 6 times 0 minus 9. It's going to be f of 0 is equal to cancel, negative 9. Okay. Seeing as I can't fit that on there, I'm going to make my y by 2's. My x, it's got to be by 1's, which means that's going to be 2, 4, 6, 8, 9. Awesome. And that means that the magic of this is that if I were to draw my axis of symmetry through here, we know that that reflects So there'd be another point 1, 2, 3 to the left that would curve through there. And what we're going to see is that our new approach is going to be a little less cumbersome than this. We're just going to find the vertex and we're going to find the y-intercept. Let's see how easy it is to find the vertex of this same problem. And we're going to do that over here. So I'm not actually going to be doing this problem. I'm going to be resolving number 1 using our new process. So I'm going to find the vertex using negative b over 2a. So negative b over 2a. What is my b? Well, negative 6. What is my a? That's negative 1. So negative negative 6 is 6. 2 divided by negative, or 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. Hey, so far so good. So I found the x part of my vertex. Let's find the y part of my vertex. And to find the y, I plug in my x, which means if we remember evaluating a function, I'm going to plug that thing in to the function. So I'm going to say, okay, f of negative 3 is equal to negative minus 6 minus 9. And I'm actually going to plug in a negative 3. So I get negative 3 squared, which is 9. Negative 3 times negative 6 is positive 18 minus 9. 18 minus 9 is 9. Negative 9 plus 9 is 0. So that means my vertex is at negative 3, comma 0, which would put us right back at that spot. And we can see that this relies on a little less, how should we say this? A little less of a cumbersome approach. This is much cleaner because many people just like the simplicity of let's find the x and plug it in. When we factor, albeit the factor will give us the zeros, if we just want to graph it and find where the maximum point is, let's just plug it in and find the vertex. Once we find the vertex, the second follow-up is we do the same thing that we would do right here, and we would plug in our 0 to find our y-intercept. And we would get f of 0 is negative 9. And we graph that. So like I said, if you like a cleaner approach and you need to find the vertex, you need to find that maximum point, most importantly, go for there. Because we lucked out and this happened to be able to be factored. So let's try the new approach on number 3. Let's find the vertex and then the y-intercept. So to find my vertex, I'm going to say x equals negative b over 2a. My b is 6, my a is 1. So negative 6 over 2 times 1. It's going to give me a negative 6 over 2, or again, I get another negative 3. Let's see where this goes. So I'm going to take that and I'm going to plug it into the equation. F of negative 3 is equal to order of operations. Negative 3 squared is 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. And this is 0. Oh, so this looks like it might be another reflection of what we just did. So let's plug in the negative 3 and see where we go. So I have my point right there. I know that's my vertex, which would have saved us a lot of time right here because we would have gotten 2 roots again of the same thing. But I found my root, or I found my vertex. Now what I'm going to do is I'm going to find my y-intercept as a second point that I can graph. So f of 0 is, let's plug in my 0 into everything. 0 squared, 0, 9. Boom. Again, I'm going to have to do this by 2's, which means it's right there. And I know the fact that it's going to reflect across my axis of symmetry, which means there's another point right over there that's going to curve through. So if I curve up to the right, I'm going to curve a mirror image to the left. Like I said, there we go. And so because this touches the axis, we'll actually be able to factor this. Anytime this touches, you're able to factor it. So let's try it on this one. This one might not be so lucky. So what I want you to do is I want you to pause the video. I want you to try the new approach and unpause it when you're done and see how you did. Okay, let's give it a shot. So with this one, I'm looking at this and I see factors of 14. I can't find any factors of 14 that would sum to 6. So I know there's no possible factors, which means that this is either going to be irrational or it's not real. So let's try it out. So x is negative b over 2a. And so my b in this case is negative 6, and my a is negative 1. So it's going to give me a 6 over negative 2. I get another negative 3. Really need to change up these questions a little bit. But regardless, I'm going to plug in my negative 3 into my function and evaluate it. That's going to give me negative 3 squared is 9, so I have a negative 9. Negative 6 times negative 3 is positive 18 minus 14. Let's see, negative 9 plus 18 is going to be 9 minus 14. 9 minus 14 is negative 5. Okay, not too bad. But now, what we've seen in the previous ones is that when I graph this point, my other point bounces off my graph. So I'm not going to graph my vertex just yet until I find my y-intercept. So let's go ahead and find the y-intercept by plugging in 0. So if I plug in 0, cancel, cancel, f of 0 is negative 14. Ooh, I'm very glad I didn't, because that means that I'm going to have to stretch this just a little bit. Let's do this by 3's, and heck, why not? Let's do this by 3's, just to keep it even. So if my vertex is at negative 3, negative 5, negative 3, negative 3, 4, 5, it's right there. And I now have another point at 0, 3, 6, 9, 12, 13, and 14. 14. And I know that if I reflect through this central line, that means I have another point right on the other side. And that will curve like this. Perfect. And so yeah, if we tried to factor this, it doesn't touch the x-axis at all. We would have been waiting a very long time to find some combination of numbers to find when this crosses the x-axis. So this saved us some time. Let's do one more. So here I'm looking for factors of 8 that add up to 4. I have 1 and 8, which add up to 9, and I have 2 and 4, which add up to 6. So I don't have any factors. So I'm going to have to use the other method. Which means I'm going to have to plug in my negative b, which is 4, my a, which is a 1. So if I have a negative 4 over 2, negative 2. Hey, we got something other than a negative 3. Progress. So let's plug in that negative 2 and see what we get. Plug in the negative 2. That's going to give us negative 2 squared is 4. 4 times negative 2 is negative 8, plus 8. I know those cancel out, so it's just 4. So there's my vertex, negative 2, comma, 4. And then as we did earlier, we're going to go ahead and we're going to plug in our y-intercept, just so we can have some sense of scale. Cancel, cancel. So my y-intercept is 8. So negative 2, 4, and 8. I think I'm going to be able to get away with scaling this by a factor of 2. So for my vertex, I'm going to go negative 2 to 4. And I have my vertex. I know my y-intercept is at 0, 2, 4, 6, 8. And I'm actually going to draw my axis symmetry in green, because I feel like the orange on red is a little misleading. So I know that if I have a point 1 to the right, I'll also have a point 1 to the left. Boom, there we go. And so just like before, this actually doesn't touch the axis. So if we tried to factor that, we'd be waiting a very long time. Okay. Last question. Go ahead, pause the video, try out number 9, and see how you do when you unpause it. Okay, let's take a look. I'm going to assume now, just by the trend we've seen, that factors of 66 are probably not going to add up to 16. But x equals negative b over 2a. We have a better way to do this. So my b in this case is a negative 16. My a in this case is a 1. So negative 16 is positive 16 divided by 2. I get 8. Ooh. And so if I take that 8 and I plug it in, I'm going to plug 8 into my function. See, 8 squared is going to give me 64. 16 times 8, okay. Well, 6 times 8 is 48. 10 times 8 is 80. 80 and 48 make 128 plus 66. I'm going to kind of skip around this and say 64 plus 66. 64 plus 6 is 70. 70 plus 60 is 130. 130 minus 128 is 2. So my vertex is at 8, 2. Now I just need to find where my y-intercept is. And have any of you figured out the shortcut to finding the y-intercept? Well, when I plug in 0, the y-intercept, if you haven't noticed by now, when I plug in 0, it's always going to be that number right there. You notice that every one of our problems, the number that doesn't have an x doesn't get zeroed out. So when you're asking yourself, what's the y-intercept? At least when it's in standard form, it's always going to be your c term. But regardless, we need to be able to fit 8, 2, and 66. So that means I'm going to have to count more than by 10s. I'm going to have to count by, let's say, 15s. This is going to be a really messy graph. So 8, 2. So 8 is going to be about halfway. 2 is going to be just barely above the line. 66, okay, so 15, 30, 45, 60. It's going to be roughly there. And we know because if we have an axis of symmetry that goes right here, and I have a point on the left, I'm also going to have a point on the right, which is going to make this very narrow and skinny quadratic. And there we go. So today what we're going to be working on is a process called completing the square. And completing the square is very useful if we're wanting to turn a quadratic in standard form into vertex form. Why would we want to do that? Well, if we want to see where the vertexes move to. And so we're going to do something where we create an artificial perfect square trinomial. And this is basically what we're going to be doing, is we're going to be adding b over 2 squared. Why are we going to be doing that? Well, let's take a look. Now, if we remember, a perfect square trinomial is something that we can easily factor. And the idea is that it's a trinomial, 1, 2, 3 terms, and I have a perfect square on each end. So I have x squared, which is a perfect square. I need something that is a perfect square. And if I factor something that's a perfect square trinomial, that means it's going to reduce down to something like x plus something squared. So I want to know, what do I need to add that squares up perfectly, that when I FOIL this, so when I'm checking my work, when I say x plus that something, x plus that something, let's call that something, let's call it b. Let's take a look at what happens when I actually work out this FOIL. So I multiply first times first, outer times outer, inner times inner, and last times last, which is going to give me an x squared. Then we have right here a bx. So x times b, x times b. So I have another bx. And then when I multiply b times b, I have b squared. And so I can combine these two middle terms into an x squared plus 2 bx plus b squared. So assuming that this follows that general format, I have an x squared. This is going to be twice b. This is going to be b squared. So if I want to figure out what b is, what this thing is, I have to divide it in half. And so, okay, what's half of 12? If 12 is 2b, well, then that means b is 6. So I'm going to add 6 squared. So what am I going to add? I'm going to add 36. That's what's in my little box. Which means that if I were to perfect square trinomial that, what is 36? What's the square root of that? 6. There we go. So what am I adding to make this a perfect square trinomial? I'm going to add 36 because that's half of that squared, which allows me to very quickly and very effectively factor that down into the square root plus the square root. We don't need to figure out, well, 1 times 36, what factors of 36 make a sum of 12, because I know it's going to be the square root. So let's try that on another one. Now, knowing that this general rule, and this is how we figure it out, I know that if 6 is twice b, what's half of this 6? Well, half of the 6 is negative, I'm going to draw that in red, negative 3, because half of negative 6 is negative 3, and that's going to be how I factor this. But what do I need to add over here to allow me to do this? Well, I'm going to have to take that negative 3 and square it, which means that I've actually added 9. So if I were to factor that, again, if you haven't followed through with this yet, if I add 9, which is half of that squared, I could very quickly and very easily factor this. Because let's look, for example, what it would look like. X squared minus 6x plus 9. Well, what you would do is you'd say, okay, 1 times 9 is 9. It's a positive 9, which means we're summing up the factors of 9. 1 and 9, 3 and 3. Okay, well, 1 and 9 make 10, which is not a 6. 3 and 3 make 6. I'd use those. So I'd split 6x into 3 and 3. So I'd say x squared minus 3x plus 9. What we would then do is we'd factor out the GCFs, which is an x and a negative 3, which means that my x and my negative 3, let's see, x squared divided by x is x, negative 3x divided by x is negative 3. Same thing over here, negative 3x divided by negative 3 is x, 9 divided by negative 3 is negative 3. So I know my two factors are x minus 3 and x minus 3, or x minus 3 squared. So we've proven that if I add 9, it factors down into this. Awesome. So what I want you guys to try is I want you to try this one. So go ahead, pause the video, see what you would need to add in order to be able to factor this in one step. Resume the video when you're done. Okay? Now this one's a little tricky because this one's an odd number. I know that in order to do that, I'm going to say, okay, if that is twice my b, then I need to divide that by 2. So I know that in this case, my b is equal to 9 over 2. Okay? Well, my last term is b squared, so what is 9 over 2 squared? Well, let's see, 9 squared is 81, 2 squared is 4. So I'm going to add 81 over 4. Awesome. And so I know if I add 81 over 4, I can factor that down to x plus that. So no math necessary. Actually, we've already done the math, so it's going to be x plus, remember our b of 9 halves? 9 halves squared. We don't need to factor it. We don't need to prove that we can factor it. We just say, hey, I know that if 9 is twice my b, half of 9 is 9 halves. Let's square it, 81 fourths, so therefore I can factor this in one step. Perfect. And so we can do that with literally any quadratic if we want to convert it into vertex form. Again, the skill that we're trying to do here is we're trying to say, okay, I can't do it right now because I see the fact that I have a 2. So one of the ways to get rid of that, so I have a perfect square, is I'm going to divide out a 2. And I'm going to say, okay, x squared plus 4x plus whatever this square divided by 2 is. So I have new square. In this case, my b, half of 4 is 2. 2 squared is 4. So my b is 2. So what I know I'm allowed to do is I'm allowed to say x plus 2 squared. There we go. Now, so what did we actually add? Well, if my b is 2, that's a 4. Distribute that back in, I get 8. There we go. So now that we've kind of seen it in action a few times, let's go ahead and let's give it a shot with an actual equation. And so this is an equation in standard form, and we want to put it in vertex form using the scale that we just learned. So what we're going to do is we're going to say, okay, what does my b need to be in order to factor this? Well, if 10 is twice that, my b is 5. So what is 5 squared? Well, we're going to add 25. Well, I can't necessarily just do that with an equation. If I add 25, I have to take away 25 because now this is balanced. But what it does allow me to do is it does allow me to factor this part. And so what we get is we said, okay, if b is 5, this is an x plus 5 squared. Where does the minus 25 go? It just stays out here on the right. And that's it. We know our vertex is found at, just to prove a point, our vertex is at -5, -25. Just as a side note. Okay, so let's try one more. I want to convert this to vertex form, which means that needs to be a perfect square. What perfect square? Well, if 4 is twice that, that means my b is 2 again. So what I'm going to have to do is I'm going to have to add, well, what is 2 squared? 4. So I'm going to say x squared plus 4x. I'm going to add 4, which means I'm going to have to take away 4 as well, because remember, these, just like before, are going to cancel out. Let's not forget about plus 8. Plus 8 still exists. But again, what it allows us to quickly do is convert this to an x plus 2 squared. Condense this. 8 minus 4 is 4. Boom. And so just to prove our point, our vertex over here is at -2, 4, just to show off. Okay. So I want you to use everything that we've learned today on number 13. Turn that into a perfect square trinomial, factor it so we can find our vertex. Unpause the video when you're done. So let's see how we did. I know that if b is twice 16, b is, in this case, a -8. And I know for that to be true, I'm going to need to add 8 squared. So I'm going to add 8 squared, which is 64, and I'm also going to take it away. And let's not forget the minus 66. This allows me to say that's x minus 8 squared. And then the next thing I'll do is I'll say, okay, that's 120, 130. And if we wanted to show off, our vertex here is at 8, -130. Done. And there we go. So today we're going to be doing completing the square, where our a values are something other than 1. And the whole idea for this is we're going to factor out before we're beginning. So our first two is just a refresher for what is factoring, or what is completing the square. And the whole idea is that I want to create an artificial trinomial using these first two terms. I want to kind of push that off to the side and deal with it as it shows up. So I'm going to say x squared minus 40x, and I'm going to move that 10 over here. And that gives me some room to deal with this. And I know for a perfect square trinomial, this is going to be twice the square root of this term. So I'm going to cut that in half. Half of 40 is 20. So I'm actually going to be adding 20 squared, which means if I add it on the same side, add it and subtract it. Add and subtract 20 squared. What this does right here is over here, this allows me to factor very quickly x minus 20 squared. And then I just deal with what's over here. Well, that's going to be minus 400 plus 10. So all in all, that's going to be x minus 20 squared minus 390. So let's take a look at another one. That one worked pretty well because I had an even number, so it was easy to divide, but it's no different if I have fractions or odd numbers. I'm going to shove that thing off to the side and say x squared plus 5x and move my 11/4 way over there so that I can say, okay, what's half of 5? That's 5 halves, whatever that thing is, squared. If I add it, I'm going to take it away. 5 halves squared, because I know that that is going to work out to 0. But it does allow me to very quickly factor this into an x plus 5 halves squared. And then I just kind of deal with whatever this is over here. Let's see, 5 halves squared is going to be minus 25 fourths plus 11 fourths. That's going to be 11 minus 25. That's a negative 14 fourths. So x plus 5 halves minus 14 fourths. That reduces down to a 7 halves. So x plus 5 halves squared minus 7 halves. Perfect. So we see that even if we have fractions, square the fraction, combine these two things. Even if I have an odd number, or if I had a fraction right here, divide it in half and make sure that that's squared so we can balance these two things out, and that just poops down into this, and then we're done. So the big question of what we're dealing with today is, what happens if I have something out here? How do I deal with that? Well, the whole reason of how we deal with that, actually, let me pick a different color. I'm going to pick purple, is I just pull out a negative 1. I'm only going to pull a negative 1 out of the first two terms. I am, just like before, going to throw my 77 way over here, but it's going to give me some room for my x squared plus 18x. And I'm going to make sure this is set up for a perfect square trinomial. Now, if I were to say, okay, what's half of 18? Let's add a 9 squared. And if I were to subtract a 9 squared, that looks balanced, right? But if I were to take this a step further and FOIL this out, I'm not actually adding a 9 squared. I'm adding a 9 squared times this. So I also want to take away a 9 squared times that. So add a 9 squared times this, take away a 9 squared times that same thing. And we would see that if I were to work this out, so let's say that was a negative x squared plus 18x, actually that's a minus. So minus 18x, that's going to be a minus, let's just call it 81. We're going to simplify it. So there's my minus 81. I have plus 77. 9 squared is 81. That makes it a negative 81. That makes it a positive 81. And so we see that by multiplying this thing on the outside, we get them to balance out. And that's really what we want. But again, this makes it very easy for us to say that's x plus 9 squared. I still have my negative 1 out front, but then I just deal with whatever this is. I say, okay, well, that is 81. That's a negative 81. Now it's a positive 81. So what is 77 plus 81? Well, negative 1, x plus 9 squared. That's going to be 159. There we go. Perfect. And so let's do one more of those. What we're seeing is that if I have a number out front, my first job is to just go ahead and pull it. And then I'm going to say, okay, I'm going to divide that out, so I get an x squared. Divide that out, so I get a plus 10x. But remember, I just moved this 10 way over here. I don't actually do anything to it. I'm going to take this. Half of 10 is 5. Let's add a 5 squared, which means I take away a 5 squared times 2. Because I add a 5 squared times 2, take away a 5 squared times 2. It's going to keep my equation balanced. This very quickly factors down to an x plus 5 squared, where I still have my 2 out front, and I just deal with this as it is. 5 squared is 25, negative 25, negative 50. So there we go. So y equals 2x plus 5 squared minus 40. Perfect. And so now that we've seen that, I want you guys to pause the video, try number 9, unpause it when you're done, and see how you do. Okay. Let's take a look at how that works. So my first thought is pull out this 4. So I'm going to divide that by 4 to get an x squared. Divide that by 4, which is going to give me a 15x. Leave myself some space, plus 1. I'm going to say, what's half of 15? Well, that's 15 halves squared. If I add it, take away 15 halves squared times this thing. And that's going to give me a very easy x plus 15 halves squared times 4. And then I just deal with whatever's left over here on the end. Let's see, so 15 halves squared, that's going to be 225 over 4 plus 1 minus 225 over 4 times 4. Well, those are going to cancel out. It's going to be a plus 1 minus 225, and that's going to be a minus 224. There we go. Boom. How'd you do? And so now that we're familiar with that process of just factoring out that leading coefficient, that works even if the leading coefficient is not a whole number. So for example, this is a half, so I'm just going to factor out a 1/2. Now, what that's going to do is if I divide everything by half, remember, dividing by a half is the same thing as multiplying times 2. So that's going to turn that into a minus 20x. Minus 18. So what I'm going to do is I'm going to say, hey, that's going to be a plus a 10 squared. So plus 10 squared times 1/2. Remember, still get multiplied by that leading coefficient that I just pulled out. So that gives me the ability to say, hey, I have an x minus 10 squared. I still have my 1/2 out front, but easier now than last time is I just get to deal with that. Ooh, careful. I almost broke the cardinal rule. I added twice. That should be a minus. So if I added 10x, or added 10 squared, I take away 10 squared. So that's negative 100. Half of 100, that's going to be minus 18, minus 50. And remember, for some of you, you might say, well, no, shouldn't that be a plus? Remember, that's minus 10 squared times 1/2. Remember, the immediate base rule says that only that 10 is squared unless that negative or unless anything else is included in an additional set of parentheses. So that'd be 100 times 1/2, be negative 100 times 1/2, which is negative 50. And so right here, we're left with y is 1/2 x minus 10 squared minus 68. Perfect. And there we go.